So I'm assuming about 2, 3, or 4 plus. That's what you would be aiming for, right? Yes, no? Say something, guys. I can't understand. So you guys are really good with the telepathy thing. I'm not good with telepathy. You have to speak. Right. So it's a perfect mix. About 2 plus to 4 plus is what the industry is looking for in full stack. Probably this batch would be the perfect sync with what we are trying to give in terms of Linux, AWS, and DevOps for full stack. Remember one thing, this class is tuned towards developers. This is not a support kind of AWS DevOps. We're going to talk, or we're going to learn things which are required by the developers, specifically Java developers. So when we say Linux, we are saying Linux for Java developers. And when we say AWS or cloud, we are saying AWS or cloud for developers, specifically Java developers. We're going to see some services on AWS which will work exclusively for Java only, which will be directly discussed in an interview if you put it in your resume. The same way, when we say DevOps, we are talking specifically DevOps related to Java, like Java, GitHub, Git, Maven, Gradle, continuous integration, Jenkins, all that part. Purely Java related DevOps. All right. So we'll go deep into what are those specific areas as we move on. There are some questions about Lambda functions and everything. Yeah, we will discuss about Lambda functions. Lambda functions specifically to Java, we will talk about those things. Lambda functions, by the way, is one of the AWS services, which will help you quickly run your AWS or your Java code on AWS. We'll talk about those things. So before we start ahead and move into things, let's first talk about what we're going to discuss about the path. Means what is Linux syllabus? What's your AWS syllabus that we're going to talk about? Then what part of DevOps we're going to talk about. Now, to make things easy, I'm going to show you the same PDF that I have sent as part of the syllabus. You can see it, right? So the first thing, if you see, this is Linux. The second one is AWS. And the third one, DevOps. In each of these things, let me start with Linux first, towards the end. This is the whole Linux syllabus we are going to talk about. Now, before we go into the actual syllabus, let me tell you why we need Linux. Why are we even learning Linux? You are a Java developer, right? Why do you need Linux? Or even before that, what is Linux? Let's talk that. Any ideas? What is Linux? It's an operating system. Bang on, exactly. What it does. Why do we need an operating system? We already have Windows, right? Nice. You right click and everything is available. Why do we need Linux?
Multi-user operating system.
What's that? Sorry?
Multi-user.
More security.
System. More security.
Free one. Yeah.
Yes.
Yeah, open source. Yeah.
Linux is open source. It gives more security.
Let's see what others say. Linux is safety, free, more security, safety, security, open source. Yeah, pretty much all of them are correct. The two main reasons why Linux is used is, one is obviously security. The second thing is open source, means the cost is less. There is a more practical reason why Linux is used. You can automate a lot of things on Linux. Like you're writing a JavaScript, right? The same way, I can write a bash script on Linux to do everything that we are doing right now. Linux is purely automation. And it can take more load compared to Windows. For example, Windows is there, right? You are using all Windows. How many users you think can connect to this laptop and work at a time? Pick up a number. 5, 10. All of you are connected to the same laptop. This laptop has about 16 GB RAM with a i5 processor. 1 TB hard disk. So if we allow you to connect to this laptop, how many users can connect and work on it? 10, 20, all of you? 10? Why do you think it cannot go beyond 10? System slow. We can increase the RAM, right? Increase the RAM, increase the hard disk, and it will be more. Even on Linux, you do the same thing. The main restriction with Windows is it's a single user operating system. Multiple users cannot connect to this server at a time. It happened only recently that it allows multiple people to connect. Until now, if I'm logged into this server, you cannot log in. If you log in, I will be logged out, kicked out. That's the reason why Windows could not be moved into server. But why didn't Windows include that feature? It's just a technology, right? If Linux can do that, Windows, Bill Gates also is pretty smart guy. He should have done it. Why didn't he do it? That was because Windows was predominantly a desktop operating system. Means from a business angle, they did not try to go into server business ever. They always left it to Linux. Now what they did is, they started promoting the Linux also. So you will see Linux being promoted by Microsoft.
Yes.
All right. So right now, if we say why we are going into Linux, let's get back to our Linux part. Why we are learning Linux? Because everything that you develop, all your Java programs, have to be run on Linux servers eventually. So even though you develop everything on a Windows laptop or a Windows desktop kind of thing, using your Eclipse and other IDEs, your jar file that you create or a var file that you create has to go into a Linux server. When it goes into the Linux server, if there are issues on the Linux server, again, you will be called back to sort those things, basic problems, troubleshooting. Even before that, the basic testing that you do before you give it to testers, you have to do it on Linux servers. So what we are learning here with these commands is only basics of Linux. So we're going to see what is Linux in general, what is the difference between Linux and Windows. We will also see another word called Unix. You might have heard Unix. So there's a difference between Windows, Unix, and Linux. So we will briefly see what the difference is. Now, the reason why you have to understand these things is when you talk to the clients, or when you are talking to your project, other peers, all these words get used based on the context. Some people might be working on specific Unix things. Some people might be working on specific Linux things. They're not exactly same, but also they are not completely different. Right? So Unix and Linux are slightly different, but once you learn one, you will understand the other parts also. So we will see how they are different in a quick way. Then comes our most important thing. We will see about 100 commands related to each of these categories. We will see the general directory structure of Windows versus Linux versus Mac. Then what is a laptop versus server? Then we will see the general commands like cd, pwd, all these things. Then we will see how do you move around in a Linux environment, just like how you move in a Windows environment. When you log into your Windows laptop, what do you normally do? Let's say you got your friend's laptop. You got your password also. So what do you do first? Find out where the movies are, isn't it? Movies, songs. Perfect. So the same way, when you log into a Linux system, you have to understand how the system is structured. Simple thing like, what's the RAM this server has? Can you run your program or not? Or what's the CPU this server has? So those are the common things that you will try to understand. Then disk space related things. Then you will see how to install softwares. Then you will see something related to zipping, unzipping. That's called bundling and compressing. Then a very important thing related to process, which is called task manager in your Windows. You see the task manager on Windows, let's say, quickly. The same thing can be seen on a Linux laptop or Linux server also. This is basically task manager. This is where you'll see all the process running on your laptop or server, the performance of each one of them, what's the CPU consumption, how much RAM is being used, what is the storage, how is it being used. Ethernet is your network cable or wireless. How much of this Ethernet is being used, that kind of thing. So we will see in Linux also how we're going to look at those things. Then we will see another important thing, guys, which is not usually available on Windows. It's a multiple system thing. Especially what we are saying is, you have two servers, assuming this is server 1 and this is server 2. You have to connect from one server to another server. This is a very common thing that you do if you are working in a project. You have all your files on your laptop. You've written, let's say, some wonderful Java code. It's all on your laptop. But unless you send it to a server, users cannot access it. Yes? So system to system communication is very important. Whether it's Windows or Linux, doesn't matter, but it usually happens in Linux. So we're going to see how multiple systems will connect with each other. And how do you transfer files from one system to another system. Then we will see some other things related to variables, defining variables, system restart, reboot, that kind of stuff. Now, once those commands are done, these are commands, and we are looking at about 100 commands, guys. Now, hear me carefully. Probably these are the only 100 commands you will ever need in your career. You don't need any more commands. Out of these 100 commands, about 80 commands I learned in the first year of my career. During the last 20 years, I've added only 20 commands. Yearly one command I'm adding, that's it. So the point here is, once you learn these 100 commands, you are one of the better users of Linux. You are very comfortable in using Linux. Now tell me one thing. How long do you think it would take for a person of your capacity to remember 100 words? 100 words. How long do you think it takes? 100 words? Can we remember in 100 minutes? No? 100 words in 100 minutes not possible, you're saying? $200 minutes? You can hear me, right? So 200 minutes? Give me a number, random. 200 minutes is approximately 3 hours. Can you remember a song in 3 hours? That would be more than 100 words. Can you, what's the latest song that you already remember? Any latest song? Fine. Okay, don't go beyond that. Okay, one day, would it be one day? Can we remember 100 words in one day? Very simple words. Maybe. Yes. Okay, somebody is saying 1 week. Fine. 1 week. So if you spend 1 week, probably 1 hour each day, your 100 commands are done. And I'll make sure you remember all those 100 commands by the time we are done with this course. We have our methods, don't worry. So these are the 100 commands we're going to learn. And remember one thing, we are talking not like a Linux administrator. We are focusing on a developer's Linux only. So we're not going to learn all the garbage a Linux administrator learns. We're going to focus on only those 100 commands that you will need as a Java developer. Some of those commands you already know. For example, jar CVF. How many of you know jar CVF? You're not going beyond your Eclipse, right? Jar CVF? Jar CVF, your directory name. You have a jar file. So you already know some of those commands.
Yes.
Those commands that you don't know, we will learn it. Don't worry. All right. So that's your Linux commands part. Let's go back here. Let's look at bash scripting. Just now we were talking about why Linux is sometimes superior than Windows. One of the reasons we said is automation. You can write scripts in Linux to make things easy. Let me give you an example. Let's say every day evening at 5 o'clock, you want to transfer one file to your internet G drive. All right. Every day, 5 o'clock, fixed schedule, no changes. How can we do it in Windows? Here is the task. Every day, 5 p.m., your file, the file name is also fixed. A.txt, let's say. The A.txt should be transferred to your G drive. How do we do that? I can't hear you, sorry. Any guesses? Anybody here?
Using shell scripting. Shell scripting.
Task scheduler. Yeah, that's a good point. But what is the task you schedule on a Windows server?
Schedule job.
So basically, you need to have some tool which triggers a command or a program that transfers this file from your laptop to your server, isn't it?
Yeah,
For
yeah.
example, let's say, let me take, draw something. So you have your laptop here, then your G drive. Now on your laptop, let's say you have a.txt. And on your G drive here, you have a folder, let's say my folder. This is your G drive. You need to have a program here, which starts every day at 5 p.m. Takes this file, sends it to G drive my folder, isn't it? Now this tool is not really available by default on Windows. On your Windows operating system, these tools are not usually available. And even if you have to write a program to do that, you have to either know Java or some Node.js or .NET, which can do this thing. Whereas on a Linux system, the 100 commands you are learning, you can use these 100 commands and little bit of shell scripting and write the program that we are talking about now. So automation is really easy if you learn bash scripting. Now, is it necessary? Is it necessary to learn bash scripting, especially for a Java developer? You already know Java, right? You can write a program in Java itself. Why learn bash scripting unnecessarily waste time? Isn't it? Sometimes what happens is you can't have a Java program everywhere. You're not allowed to install Java everywhere, on servers especially. In such a case, you can write a simple bash script to do your job. So bash scripting is going to be a value addition here. It's not a mandatory thing. Your mandatory part will be Linux commands. Whereas bash scripting is a value addition that we will try to add. Because you already know Java, learning bash scripting is going to be really easy. You already know what are variables, you already know control structures, you already know for loop, while loop, all the stuff. So writing another programming language is not really that difficult. That's the reason we are adding bash scripting into it. Means compared to somebody who does not know any programming language, it's much easier for you to learn bash scripting. But the value it adds to your resume in getting you a job is very, very high. So this is something like you're doing a smart thing by adding bash scripting. All right. So that's our Linux part. Now let's move on to the AWS part. What are we going to learn on AWS? Before we go into AWS, let me just give you something related to cloud. How many of you are familiar with what is cloud kind of? Clouds? Cloud and clouds are same? No?
Cloud is a rental-based service.
You're familiar with these three clouds, right? Let me give you that this thing. You're familiar with these three clouds? AWS, Azure, and Google Cloud?
Yes, yes.
Yeah. the pay as you go. Yeah, that's true. That's true. But even beyond that, why do we need a cloud? We already have servers. Everything is sitting in our server room. What is cloud in the first place? Any ideas?
We don't need to update our installed software every time.
Let me give you an example. I have this laptop here, right? I have all the programs installed on it. Now, if I go to Bangalore, assuming, and my laptop is broken, what happens to my work?
You
Dead
cannot
kind of?
perform.
I'll be thrown out. I can't really work anymore.
Yeah.
Instead, let's say I have this entire desktop sitting somewhere in our high-tech city, one of the buildings. All right? Entire laptop, I put it in high-tech city, one of the buildings. That building is completely secure. Nobody can enter into that building. And my laptop is completely secured in a rack, metal rack, locked. Nobody can open that lock. Nobody can touch it. 24 hours power is there. So I don't have to worry that that laptop will be shut down. And then I can connect to my laptop from anywhere just using internet connection, including my mobile. How is it now? Am I worried now that my laptop will be lost or something goes wrong with my laptop? So the first thing is connectivity. I can connect from anywhere. Now, whatever I have on there in that, usually the high-tech city building that we are calling, usually it's called a data center. Because I am connecting to my laptop over the internet, my laptop is considered to be in the cloud. I am sitting on the ground. My laptop is in the cloud. The connectivity is happening over the internet. So cloud is a very generic word, assuming the servers are somewhere. I can connect to the servers through the internet. That's all it means. Now I can put as many laptops as I want, 10, 20, 100, right? I can connect to any one of them from the laptop, from anywhere. That makes more sense? Now the more interesting point. Let's say instead of buying my own laptop, if somebody is renting it out to me on a daily basis, would it make more sense? Let's say tomorrow I want 200 laptops, only for tomorrow. Would it be better if I buy them or rent them?
Rent them.
That's precisely what cloud is. It's a rental service. It started as a rental of servers. Then slowly they've added a lot of services to it. You have a large bunch of services now that you can rent. The first thing that you are looking at here is storage. S3. I think even before that we have something else. Hold on. Yeah, this is the rental service we are talking about. EC2. These are the laptops that we just now talked about. EC2. It's called ECC. It's represented as EC2. ECC. It's called EC2. Elastic Compute Cloud. You see this thing? EC. Another C. ECC. which turns out to be EC2. The same way, ECS3 is actually SSS. Simple storage service. Like this, if you see these things, first one is a laptop being rented out or a server being rented out. The second thing is hard disk being rented out. It's exactly similar to your G drive. S3 is. Like this, there are numerous other services. This entire list of services. You see this RDS. This is a database. You must have learned SQL Server or Oracle. What? Oracle, SQL Server, PostgreSQL. One of these things, relational database service. That's what RDS means. So you can rent out databases also on AWS. The same way, there are a lot of other services that you'll see in here. CloudFront, ECS and ECR, they are related to containers and Docker. Then there is an interesting thing, Elastic Beanstalk. This is purely for developers. Using this service, you can quickly deploy your Java application using a Tomcat server. Everything is already set up. All that you do is take your jar file, put it to
Yashwant Kumar.
is ready in 1 minute. But if you do it on your own, you have to install your Tomcat server. You have to do the whole deployment on your own. Then AWS has
Some disturbance actually. We are not able to hear.
which is part of DevOps. We will talk about these things in a moment.
Yashwant Kumar, please turn off your mic.
Related things to understand how your application is working. Then we have Lambda functions, all that stuff. Very important from a development angle. Then SQS, SNS. We'll talk about all those things as we move forward. And also we'll have the most popular serverless, the API gateway. Your RESTful, REST APIs that you are building, everything goes behind this gateway. So we will see how to integrate your RESTful API through an API gateway so that users can access it. So don't worry about all these things at this point. We will be covering all these things slow and steady. Let's move on to DevOps. How many of you are familiar with what is DevOps then? Looks like there is
Development operations, sir.
a lot of noise. Guys, sorry about the noise thing for online. I'll try to get it reduced, but just give us some time. Yeah, about the DevOps thing. How many of you are familiar with DevOps? Familiarity is okay. And you know what is DevOps? Yeah, good.
It's development and operations.
Let me rephrase the question. How many of you know Git? Fantastic. If you know Git, you know DevOps.
Yes.
I know it.
Really? That's it. That's almost it. By the time you learn Git and GitHub, the developers DevOps is almost done. You see DevOps in this, you have two things in DevOps. Let me take a very interesting image here. A very interesting image. How many of these tools you know? Let me read them out. Confluence, SBT, Maven, Selenium, JUnit, Jira,
Hey, Yashwant Kumar, please turn off your mic.
Jenkins,
All of our disturbed.
DCOS, Docker, AWS, all these things together. Chef, Ansible together. Nagios, Splunk, Datadog together. Kubernetes is a separate one. If you see on the left side, up to let me hear.
Hello.
See on the left side, up to this part, this everything is DevOps.
Yashwant
See the
Kumar,
developer part?
please turn off your mic.
That's the only thing you will learn.
Hello, Yashwant. Can you turn off your mic?
The right
As we are
side
not
part
able
you are
to hear
looking
the
at is
class.
operations. You don't really learn everything about it. You'll
Hello,
just have
Anil Sir.
a basic idea of what the operations people will do.
Hello.
Whereas on the left side, the most
Hello.
important things you will see,
Hello.
Git is probably is as important as learning Java. It's okay if you don't know certain parts of Java, but if you don't know Git, probably you won't get too far in your job as a developer. But the good thing about Git is there are hardly 10 commands in Git. If you know those 10 commands, you're an expert. We're not even talking about you know Git kind of. You're an expert. If you have to say you know Git, you need to know only 3 commands. Git clone, Git push, Git pull, that's it. Probably one more Git commit. These 4 commands, you know Git. You can tell, I know Git, I know Git, I know Git. But if you want to be an expert at Git, you add 6 more commands, that's it. Guaranteed. There's nothing more in Git. But that's something that's really important. Now, Jira here is more from a project management angle. If you are into project management, that's basically a ticketing tool or bug tracking tool. Confluence is for documentation. You will learn it as you move on. Maven is the tool. This is a build tool. Probably you are using it along with Gradle. SBT, you can leave it out. Selenium is not something that you will be using very extensively. But compared to Selenium, Selenium will be used by testers, especially automation testers. This is something that you will be learning, JUnit, for unit testing. Developers have to start writing unit tests nowadays. How many of you know this thing? All developers, the entire unit testing has been moved to developers now. You will be learning something, some JUnit framework kind of thing to write basic unit test cases. You'll have to learn this thing.
Online students noise test sir post and
Enjoy
post and sir Muskan kanta post and
ఏమే వాళ్ళు పోస్ట్ ఇవ్వాలా ఎక్కడ ఉంది అది హోల్డ్ ఆన్ షీఈ్ నాట్ ద హోస్ట్ హోల్డ్ ఆన్ How do you give host? Host ఇందులో లేదు.
I think we need to log in with the
నేను
host
కాదనుకుంటా
credentials.
host.
Host credentials only you need to log in.
అనుకుంటా. No sure. Yeah. Let's come back, guys. Sorry. So our DevOps will focus on the left side part, guys. Operations part, we will not be covering too much. That's not really relevant for you. Now in this DevOps, if you go back to the syllabus part, where are we? Here we are. We will see what is DevOps first. And also there are some keywords you will see: continuous integration and continuous delivery. We will try to understand what these keywords are. Continuous integration, continuous delivery. The continuous integration part is what is usually referred to as CI. And the continuous delivery part is what is usually referred to as CD. And that's where the popular word you will come across, CI/CD. So the entire CI/CD is nothing but DevOps, developers and operations engineers. Even though we say DevOps, developers are usually associated with a set of tools. Operations people are associated with another set of tools. And that's what this image basically represents. We will be more focused on the actual tools, especially Git, we will learn extensively. Jenkins, we'll be learning extensively. We will add some parts of Maven. You already know those things. We will learn Docker, parts of it. Kubernetes also. These Nagios, Splunk, Datadog, they are more towards operations people. Monitoring tools, these are. You don't really get to use them or you don't need them. So I would say we focus more on things that we need to get a job. We'll do that. So Docker is one of the very important things. And once you learn Docker, Kubernetes comes into picture. But before Docker and Kubernetes, the basic things we'll have to learn about Git, and we'll also have to learn about Jenkins. Now, in these areas, if you pay attention here, we'll be learning these things. Nexus is another thing which is not in this image. Nexus is basically a repository. You create a var file, right? You need to put it somewhere as a storage. Where do you put your movies, normally MP3 files? On the cloud. Spotify? Anybody using Spotify? Which one? Only ads. Oh, yeah. I mean, Spotify, yeah, does give a lot of ads, true. Let's change it. Instead of Spotify, if it is only for storage, can you upload your MP3 files to G Drive? You can, right? Like a storage, simple things. The same way, if you are creating a jar file or a var file, you include a lot of frameworks, isn't it? You import a lot of stuff into your Java code. When you say import or when you say include, where is that code coming from? From your Spring Central repository? If you are writing simple Spring Boot application, or even a simple core Java application, it comes from your Spring Boot application. Now, once you bring or download it, it has to be stored somewhere, all that application together. Such application is usually stored in your Nexus. This is a repository manager we call. We will see how Nexus gets used along with Jenkins. That's part of our DevOps thing. Then we will also see a very important thing here, SDLC process. Software development life cycle, that is. Let me write it down. Software development life cycle. We'll write down detailed notes once we get into the class. Right now, you don't need anything. Software development life cycle is basically all the stages through which your software gets developed. We have seen that in our previous image. Let's go back to the image one more time. You see these boxes here? Plan, code it, build it, test it, release it, deploy it, operate it, monitor it. That's your software development life cycle. During the initial phases here, it gets developed up to build. You are the guys who is developing it. You are planning everything. You are doing the coding part. You are building it. You also participate in part of testing up to unit tests. Then the testers will come in. They do automation testing, all those things. Once the testing is done, this is where the operations people come in, the release. This is where they send it to a central server wherein users can access it. After they send it, they put it on your Tomcat server, which is called a deployment. Once the deployment is done, users will be able to access it. Now that it's sitting on your Tomcat server, somebody has to do a restart, stop, shut down everything on the Tomcat server. That is what the operations team usually do. This one. And while all this is happening, can we guarantee it's happening always? Let's say it's happening at 4 o'clock today. Can we guarantee it's happening 10 o'clock in the night? That's why you have a monitoring system. So if something is wrong, you will receive an SMS alert or you will receive a phone call. That is called monitoring. So this whole thing that you are looking at, this keeps on going, guys. This is the SDLC process. This is a continuous, never-ending, ongoing process. It starts with usually version 1, goes into version 2, version 3, version 4, version 5, probably version 500, like Matrix. It never stops. You know your Java versions keep changing, right? You are the guys who actually drive this whole process. By the time, normally what happens is, by the time you plan and deploy, operate it, your planning changes. You started with JDK 1.8. By the time operations people deploy it, you say, okay, 1.8 is not working anymore. Let's move on. Which means this entire cycle has to be repeated again. Or you change the technology. Okay, let's not use Spring Boot. We'll go ahead with some other technology. Or let's not use Hibernate anymore. Let's use the latest Kubernetes, microservices. Or let's say the RESTful API version has changed. We need to upgrade. As these things go on, the SDLC process keeps going on. While this thing is going on, these tools change. Now, this whole SDLC process changing, is it good or bad for us as a software employee? Is it good or bad? Too much work in software, is it good or bad for us employees? Guys, online, good or bad? The SDLC lifecycle. Bad?
Good only.
Bad. Everybody thinks work is bad. Some people say it's good. How many of you think it's bad? Raise your hands. It's actually good, you know. For us, all that matters is you have work every day. Not all the 8 hours, 4 hours is good. But at least you have work so that you get salary. So as long as these things are changing, we have guaranteed job, like government job. Probably you will retire in government job, but software job, you don't have to retire. You have the technology with you. You can freelance, you can moonlight, you can do all types of lights. No problems. You can do 3 different jobs at a time, freelancing, all that. So the change that we are seeing is good. Yeah, it does have a lot of pressure, but assuming you can take the pressure, you are all smart people, right? So you can take the pressure. So as long as this thing keeps changing, it's actually good for us. The cycle should keep going on. So the more versions that come out, the more Java versions that come out, that's good. The more number of DevOps tools that come out, it's good. The more things break, it's good for software engineers. It's bad for business. Don't get confused. What is bad for business is good for you. You are a software engineer. They need you to fix their problems, isn't it? So the change is actually good for us. So the whole SDLC process we are talking. Listening? We will talk in depth into all the SDLC, what each stage will constitute, what is your role in each of those stages and everything as we move on. All right. We will also look at some critical Java related tools, your Apache HTTPD server and your Apache Tomcat server from a DevOps perspective, especially how do you install it on a Linux server? How do you start these servers? How do you deploy your jar file to this Tomcat server, all that stuff. And also we'll go into some things related to Kubernetes and then Terraform also. This is the whole syllabus part, guys. I think I'm taking too much time. I'll wrap it up. This is the syllabus part. Now the duration for this whole thing is going to be about 70 to 80 days. That's what I've been told. Also here, I would like to know one thing here. You would like to go things fast or slow? This is one thing that Nagur sir was very specific about. It has to be useful to our students. That's what he mentioned to me. It should be done in such a way that our guys can get job with this. Now, getting a job, I can guarantee, but fast or slow is something that you need to tell me. I can go both ways. So we'll go slow or not too fast or in a moderate way, kind of, or we will adjust the speed as we move along. That would make sense. Initially,
Anil,
we will go slow until I'm used to you or you should get used to me. How is that? How does that work? I'll get used to you. Don't worry. I'll get used to your pace. We will go slow initially until you understand the very fundamentals of all these things. Remember all the 3 things that we are talking here: Linux, your AWS, and your DevOps. These are extremely crucial things, but they are not central. Means, will you get a job if you don't know DevOps? Probably not. But will you get a job only if you know only DevOps? No, you won't get a job. You should know your Java. That's mandatory. On top of it, we should know these things. But there's an important point here. Instead of going too deep into Java, if you add these additional DevOps, AWS, Linux things, it'll add more value to your resume. Because you are all saying you have 2+ to 4+, 5+, that's it, right? you're not expected to be an advanced Java developer. You're a junior software engineer or at max senior software engineer, right? So if you know Java decently, and means probably you are halfway through your full stack course here at Durga Soft or in Nagur Sir's class. By the time, if you have decent exposure to DevOps, AWS, and cloud, probably you can start searching for a job. When are you targeting to get a job? Let's see, that's an interesting question. 2 months, 3 months, so by next Feb, 2023 Feb, is that a reasonable date? Or too far away? Anybody who are trying to get a job in December 2022? No, we are in holiday mode, is it? Festival, guys, festival. January, anybody? 2023 January. Right now, it's a kind of luck and bad luck. I don't know. It's a lean period. It's called a code freeze. Code freeze basically means the word. Let me give you the word itself. It's called a code freeze. This is a festival season for all American clients, right? Christmas is coming. So they don't want to touch their software. They are scared that we will spoil it. So this usually December and January are usually code freeze. That's where you will have little less recruitment. The recruitment picks up usually during the first week of Feb. So shall we target Feb of 2023 to get a job? You will be good with your Java part by then. I can guarantee these 3 things I'll make you experts. What about Java part? You'll be ready with that? Fantastic. Fantastic. You just need that drive, guys. Full stack is really on fire at this point of time. If you know even 20, 30%, you can get a job. Really, we are really struggling to find people. With that, and if you can show this image and talk about this image for 5 minutes, good. You are good to go. You are hired. And just talk what is there on this image, what this tool does. That's it. Just like we did that. All right. So this is about 70 to 80 days, guys. And our focus will be more towards 2 things. One is it's developer focused. And the second one, it's going to be specific to Java and job oriented. Which means we will focus more on the real-time way of doing stuff rather than only theoretical, which means we're going to have hands-on plus the theory part that anyway we are going to do. So first, you will understand the concept. I'll try to explain it to you as clearly as possible. And once you are comfortable with the concept part, we'll get on to hands-on. How are you planning on doing hands-on thing? If I give you exercises which can be done online, will you do it? You don't need a laptop here, but if you, for those who are online anyway, they can do it from anywhere. But if you are offline, we can have a set of hands-on exercises that you can do. Right? We'll do that. And will you be open for a quiz kind of thing, competitions? No? No tests and quizzes? We don't like them. We'll have some fun, don't worry. So even though we are doing an offline, online mode, most of these things will be in such a way that you can do it from anywhere. And some of these things we are planning on doing completely hands-on model. Means once the theory part is done, I will show you how to do the hands-on, definitely. We will also have certain exercises that you can do on your own. Make sense? Right? Now, before we go in there, is hands-on really necessary? Is it not enough if we know the concept? Interviews are anyway theory, right? Why do we need hands-on? Nobody is asking you to execute a Java program or run a Jenkins job in an interview. You need them to survive in the job. On day one, what are you going to do? Somebody will ask you to, okay, go ahead, quickly run a Jenkins job or push the code to GitHub. The team lead comes and says, okay, Ramesh, go ahead, push the code to GitHub. What are you going to do? Refer back to your notes. It's okay to refer back to your notes, nothing wrong with it. But if you already know it, it makes a lot more sense because you already know the concept. Doing a hands-on will not be much, difficult. It will also help you understand the concept more clearly. Any hands-on. So we'll try to focus or balance our course, both theory and hands-on part, right? And one more important thing, the pace at which I am going, is it too fast, too slow? Am I too fast? Am I too slow? Right. I'll slow down if required. All right. You ask me to repeat something, I'll repeat, not a problem. Usually, we will try to slow down much lesser speed during our classes. All right. Apart from this, the class is going to be 6 to 7:15 or 7:30 at max. But it will start at 6 p.m. That's something that we want to make sure we're starting on time. About 7:15 to 7:30. That's your usual class time? 1 hour, 15 minutes, 1 hour, 30 minutes. And if you have any questions, anything, I'll be able to answer towards the end of every class. All right. Apart from this, a syllabus is there if you need. About the notes part, 7 Oracle class, okay, 7:10, okay. We will see how we can manage the Oracle class. I'm not sure. So we'll try to see how we can adjust it. I'll talk to Nagur sir. He'll tell me somewhere. All right. The next thing is about your notes. You're going to have two types of notes. One is the running notes that we normally do here, or some things that you normally write or your notebook or anything. Usually I'll push it to a central G drive. You can access it from there. Apart from that, we are also going to give you a day-by-day official PDF-based notes, wherein all the points that I am listing out, key points, I'll list out in that note so that you can refer to that in a quick way. Means, let's say you want to refer this last 1 week notes in a single go. So you open that PDF, you quickly go through each of those points and you're done. And that notes will also have key points related to your interviews, things that you should focus on, things you should repeat again and again if you are trying to attend an interview, that kind of thing. Whereas your running notes is things that we talk normally here in the class while you try to understand the concepts. All right, make sense? What about the videos? Yes, we will have videos. I think everything is being recorded. All those videos will be given to you. Please contact our admin. They will have it available to you. Or if you don't have them available, you can also ping me. I'll try to find out how to get them. Apart from this, any other class, any other questions, anything else I missed?
Yeah, hi Anil. Myself Sharath here. I have one quick question for you. So are you gonna take Ansible and Terraform as well in the course?
Yeah. There's another thing about the prerequisites. Prerequisites, there are no prerequisites for this, guys. I'm not assuming that you know anything. Even though this course is focused towards specific Java developers, I'm not assuming that you already know Java or you finished any of those things. We will usually go at a very ground level, assuming you don't know anything. Like I'm teaching you in your college. You don't know anything, you're just sitting here so that you can understand everything. Let's say 0, 100, 200. I'm going to start from -100. Assuming you don't know anything. I also expect that you ask me questions, any questions, it's perfectly fine. In the class, if possible, or once the class is done, I'll be available here for some time. You can ask me, talk to me also. All right. If you are online, you can post it to channel, or even if you are sitting here, you can post it online, I think. Any of you do that? You should do that. That's a good one. So we're not assuming any prerequisites here. So feel free to ask me any kind of questions. Feel free to ask me any kind of career advice. Probably I've trained enough people to know what you need. Even right now, when we are going for mass recruitment, we really look for certain things. And I can really tell you those tips that you need to get your job as quickly as possible. Probably by March, you can actually get a job. Even if you're starting your core Java now. All right. It also requires another thing. It also requires a little bit of work from your side. I'm assuming you already expected that part, right? So there will be little, even though we do have a lot of fun in this whole training and everything, but unless we all put some effort from your side and my side, performing in an interview is going to be a little tough. So make sure you're just referring to our notes every day along with your Java stuff. You're good to go.
Anil,
and the good thing about software is it's like a running race where everybody wins. Everybody gets a job. Only thing is you just have to finish the race. Doesn't matter. You don't have to come first. You just run the whole race. That's it. Fast, slow, doesn't matter. Everybody can go at your own pace. You will get a job. Especially for Java. So you're really at a very crucial junction where the whole technology is moving forward and Java is becoming more and more popular. So I'm hoping you will get a job in the next 2-3 months. I really want you to, work with me. I want to help you get a job. And this DevOps, Linux, AWS, they can actually get you a job if you are decently good with your Java. Halfway through your full stack course, you can get a job. Shall we do that?
Anil Venkatesh.
Fantastic. So I would like to stop here. Thank you very much for your patience. Tomorrow we will start at the same time, 6 o'clock. I'll see you tomorrow. All right. If you still have any questions, I'll be here. You can talk to me. Or online also, I'll be available for some more time. You can ask me any questions. Thank you very much, guys. We can discuss.
Hi, Anil. This is Venkatesh. Are you able to hear? Hello?
Yeah, we are able to hear you.
Yeah, what are the services are you able to provide in AWS? How many services are you going to explain in this course?
Seems they're on mute.
First Linux. Linux about 3 weeks, but 3 weeks. But తర్వాత AWS start చేస్తాం. AWS లో క్లౌడ్ బేసిక్స్ అయ్యాక DevOps బేసిక్స్ పడుతుంది. ఎందుకంటే AWS లో మళ్ళీ DevOps. సో AWS లో మనం DevOps కి వెళ్ళేసరికి DevOps బేసిక్ ఐడియా ఉంటే AWS DevOps కూడా కొంత అర్థం అవుతుంది. Linux 3 weeks దాకా పడుతుంది. Yeah, అదే బెటర్. Yeah.
Sir, cloud is not a coding program, also tool.
Cloud is set of tools. It's not a coding program. Only coding you will have in cloud is Terraform. And Terraform developers usually don't do any Terraform. Operations people do Terraform. So cloud, if you ask me, there is no coding in cloud. No, not much.
Coding is not.
You are a Java developer, right?
Yes.
Coding is actually easy. That's what Nagur sir says.
No, sir, coding is.
It's okay. Even the cloud does not have that much coding compared to a developer. So it does, but you can choose anything. Both are good nowadays.
Tools programming.
Yeah. Anything you can choose.
Here I came for Linux.
Yeah, Linux part is good. That's it's 3 weeks. It will take about 3 weeks. Initially, we'll go a little slow. So it's going to take about 3 weeks. Full stack ఇప్పుడు అవసరం లేదు. కోర్ జావా మీకు లెనెక్స్ బేసిక్స్ 100 కమాండ్స్ లో మనం 50 చెప్పినా చాలు. నా ఎక్స్పెక్టేషన్ మీరు 50 గుర్తుంటాయని. తర్వాత డెవాప్స్ లో గిట్ హబ్ జంకిన్స్. డాకర్ వస్తే మంచిది, రాకపోయినా పర్లేదు. బట్ గిట్ హబ్ జంకిన్స్ వచ్చాయంటే చాలు మీకు. ఫ్రంట్ ఎండ్ ఏదైనా యాడ్ అయిందంటే గుడ్. రియాక్ట్ ఏదైనా, రియాక్ట్ ఆర్ యాంగులర్. రియాక్ట్ ఇంతకుముందు బాగుండేది, బట్ కొంచెం తగ్గింది. యాంగులర్ is more popular, getting more popular. అంటే ఫుల్ స్టాక్ ఇస్ వాస్ట్, అంత అవసరం లేదు.
Hello.
3 weeks Linux, then we have 30 days about first 30 days AWS, then DevOps. So about 4 to 5 weeks AWS and DevOps. Koncham it will be a mix of AWS and DevOps. Endukante DevOps tools can be implemented on AWS. So DevOps ni separate cheste em avuddi ante adokati idokati anpistundi, but actually DevOps can be done on AWS. So we'll learn little bit of AWS, then go a little bit into DevOps, come back here, and then go deep into DevOps. Mix and match just so that it's useful for most of the things. Yes, most of the things. Non-IT background, if you can learn Java, if you are willing to. If you are not willing to learn Java, then మీరు DevOps pure గా వెళ్ళొచ్చు. DevOps with cloud, DevOps AWS వెళ్ళొచ్చు. సో దానికి కూడా అంటే ఈ మూడు మీరు బేస్ చేసుకొని, you don't understand, okay fine, you can if you are not willing to get into Java, you can start with DevOps initially and then slowly get into little bit of AWS, but on operations side. So you start with Linux, basic Linux commands, everything. And once that is done, AWS basics, then you go deep into DevOps. That way, there are a lot of jobs. Now, the reason is, as the development recruitment increases, the operations side recruitment also has to increase, because the whole business budget increases. Yeah.
Hello. What about the people who want to get into the full
3 weeks
role?
Linux. So yeah, most likely until December end we'll have Linux.
Hello.
Yeah, I'll start in January. Associate, architect, associate, professional, 2 certificates, then all specialty certifications. Then developer associate is there. We are focusing more on developer associate, not on architect associate. So the developer associate, most of those things are covered. But our focus is not really on getting a certification, because certification has a lot of theoretical parts. But if somebody is keen on getting a certification, I can give them additional material. They can just go through. Our focus will be more on how the developers, Java developers, will get benefited out of AWS from a developer angle. If you need any additional material or any additional, sessions or something, I can provide it. That's not a problem. Just let me know. And most of these things that we are covering, they are overlap. Even though we say developer and architect, 90% of things are overlap, because this is basic, associate level certification, right? So the developer and architect, both services are overlap. So only there will be a 10% difference. So depending on what you are targeting, let's say you are targeting developer associate, you will learn the 10% of developer. If you are targeting the operations side, you will learn the 10% of operations. But other than that, initially everybody has to learn most of the things.
Hello. What about the people who want to get?
It will be burden. It will be burden. That's why what happens is, only, even though we are listing out everything, only some of them you go actually deep into. For example, API gateway is one thing that is extremely important. Lambda functions is a little more important than beanstalk is something that gets used very often. Yeah. So we will, you will master core Java, and then we will master about 5 to 7 AWS services, which are very commonly used. If you know these very commonly used services, you can get through an interview and you can also comfortably work in a job. Later, during the job, if you get any additional service, you can quickly go through a video and learn. You will have enough time at that point. Yeah, that's why even in interviews, they don't go beyond these 5, 6 services, because it's like you said, it's not possible to remember everything or know everything. AWS has about 200 services. Obviously, it's not possible to know everything. So what normally people do is about 5 to 7 services you need. We will learn only those 5 to 7 services. That will be more than enough for regular work. And that's what the interviewers also look. For example, if you go for a regular interview, Java interview, and you say, I know a little bit of AWS, they're only going to ask you 2 or 3. One thing is beanstalk, they'll ask. Then API gateway, very common thing. Then S3. Lambda functions. If at all, you answer these 3 questions, they go to Lambda. Other than that, they don't go beyond that. But AWS, it gives a lot of services, but they're not necessary. Right now, just focus on 4 or 5 services. I'll tell you what those services are. I'll also give you very key points of how you should present yourself in an interview. So like something, for example, let's say somebody asks you what is API gateway? What do you know about API gateway? I'm going to give you 3 points. You just have to remember those 3 points and give it to them. That's it, done. No more questions asked.
Hello.
That's how we orient towards interview.
Hello, sir. Hello.
Right? Makes sense. Yeah. Any other questions? Gavin?
Hello. If you want to get into the full DevOps role, then
before knowing? No, not necessary. Not necessary. We're going to keep it very simple, up to only jar file. If you don't know jar, I'll use zip. That's also fine. Java is not at all necessary, but you joined Java session already, then that's more than enough. If you know what is a class and object, that's more than enough. That's Java, enough Java. That's enough Java, more than enough Java. And by the time we finish, Linux, and then we enter into DevOps part, you will know enough Java. Enough Java.
Hello.
So it started already today. It started.
Hello.
The actual content. We'll see it tomorrow. It'll be a little slow, but we'll start. We'll start with what is Linux stands.
Hello.
What about the pace? Is it too fast or it's too slow? You're able to handle it? Otherwise, I'll slow down a little bit. Okay, any questions?
Hello. If somebody wants to get into the
thanks,
full
guys.
day. Hello.
Which one? Okay. When is the joining date? They're holding all the offers. Wipro is very infamous for that. They always do that. Every year they do that. They release offers, you know. But that's fine. Even if they hold back their offer, you will still be able to learn these things and get on with something.
Hello, sir. If somebody wants to get into the full DevOps role, then
you can. Anyway, because you joined already Java, so this is going to be very more, you know, value addition to your whole curriculum. And if the markets rebound and Wipro asks you to come back, well and good. You renegotiate your package because you know more technologies. Really, you can do that. They'll allow. You can talk to HR. You tell them I learned all these technologies. I spent a lot of money and I'm more knowledgeable now. So give me more things. You can do that. Yeah. Angel Manapudu, we're done.
hello. Hello.
Hello.
Stop
Hello.
sharing.
Hello, sir.
Recording apala.
Hello.
Oh, we're able to see the screen, and shall we start? Good. So the first thing, I'm not going to go into the commands or anything. No technology, nothing stuff. We'll first try to understand why all this Linux and how is it different from Windows, like we talked yesterday. Because all of you are used to Windows, if we can compare the new operating system with something that you already know, it'll be easy. All right. So before I give into all the technology stuff, let's say what you know about. What do you know or what you think Linux and how it's different from Windows? Let me just drag an image I pull. So we are trying to see majorly these three operating systems, guys. Windows, that's what you always know about. I think everybody in the world knows about Windows by now. Our fathers, their fathers. And Mac and Linux are two other things that we slowly try to learn. Mac is like your iPhone. You're all familiar with the iPhone, right? So that is Mac. We will come there in a moment. Let's try to focus on our current thing. Windows versus Unix for now. Leave the Linux also, the third part. We will talk about it later. Windows versus Unix. Any inputs? Unix, Linux, not aware, only Windows. Okay. A lot of people seem to know only Windows. How many of you do not know Unix at all? Never heard of the word Unix? Not yesterday, before yesterday. That was a good one, kind of. Before yesterday, if you haven't heard of Unix or Linux, one of these two things, can you just, give me a hint? That's good. That's good. So majority of you heard about the word at least Unix or Linux. It's okay if you don't know it, but we will learn that. But you know there is something called Unix and Linux. And you also know it's an operating system just like Windows. That's good. Half of our work is finished then. All that we have to do is how to use it, right? Right, let's see that then. So Windows versus Unix. I'm going to give it more like how we use it. For example, the Windows thing, you're looking at the screen. Majorly, Windows is what you are looking at. It's a drag and drag or right click, do stuff. And when you go to this interface, you get the nice menus here. Then we have all these apps like I opened here, a browser app, or you have the complete directory structure here. You can go through the entire directory structure, right? So from a user's point of view, basically you have set of files in a Windows operating system, and you play or use those files. If it is a MP3 file, you play the song. If it is a MP4 file, you play a video. If it is a text file like Notepad, you open a Notepad and then try to edit something or write something. If it is a PDF document or something, you will open the PDF document and then read that. So that's what you normally do. But on the background, let's see what exactly Windows is or how it is different from Linux. Now, Windows, the first main thing is when we log into Windows operating system, let me draw a diagram here so that you can understand it quickly. Let's assume this is your Windows box, all right? Windows, your laptop, something that we are using right now. Now, if you are a user, assuming you are a user here, and you try to connect to this thing, to this Windows, sorry. This thing, all right? Only one user can be connected at any point of time. Like we talked about this yesterday. If you also have to connect to the same user or same Windows system, this user has to log out. For that reason, it's usually called a console-based operating system. Consoles are like, you remember the old days, we used to have a TV kind of thing, black and white TV. And you can plug in one, your cable plug in into it and you watch it. Now, at the beginning of this operating systems, everything, we are talking somewhere in 1950. This is when we're talking 1950 almost. This is when you're, sorry about this. (1950), this is when your operating systems have started developing. You will remember a word 8086 processor. 808, if you are from a computer background or electronics background, you have this lab in your college, 8085 or 8086 processors. These are the original CPUs, even before your Pentium processors came in, then i3, i4, now i5 you have, i7 you have. The next generation processors are Xeon processors. And the next generation computers are quantum computers. Probably 10 years from now, you will be working on one quantum computer. Right now, what we are talking about is a very old generation computers. Let's have a quick look at old generation computers, a console-based this thing. I'll quickly go to Google Images, all right? Let's sort of console 1950 computers. And these were one of once upon a time computers. We are talking about this. This is used to be called a console. So at any point of time, only one person can connect to it. Nothing more, because they're pretty old and there are not too many sockets. So these are console-based operating systems, and based on these operating systems, Windows was developed. All right. And initially, Windows focused only on allowing one user at a time. That's more than enough for them. Now, at the same time, or even before Windows, there was another operating system. It's not exactly Unix. How many of you know C? The word C programming language. Even before C, there was B and A also. That's the reason it's called C. All right? You know that. It's not, I'm not joking. Serious. Really? So there was a B and A also, programming languages. How many of you know ADA? ADA is a programming language. 1950 we are talking. All right? After B came in C. Now, with C, these 8086 processors used to be run. It's usually called assembly language. All right? They used to write a program called copy. Similar to what you write in Java. This is a function call, right? Method call. Something. So this started in C somewhere very long back. We're talking 1950s, 1960s. Now at that time, Windows was not there. Even before Windows we are talking. So then, for this specific operating system, they allow multiple logins. Means I am logged in, you can also log in with a different user. So what we have here is, for Windows, you have only one user, whereas, let me delete this thing. So if you are on a, let's call it Unix. We're not even calling, let's call it Unix. Instead of one user, like we have here, instead of this thing, we can have multiple such users. If I simply copy paste it, right? You can have another user, you can have another user. So let's call this user 1. Let's call this user 2. Let's call this user 3. Now on a Unix system, all the 3 users can connect. At a time we are talking. So this user can connect. This user can connect. All right. And this user also can connect. Any number of users. Now, it's not just user 1, user 2, user 3. Means we're talking 3 different users, right? It's not necessary that they have to be 3. The same user, user 1, can connect multiple times also. It's like you have multiple users, same user logged in at a time, and also you have different set of users also logged. Now, this model of logging in is usually called a terminal-based operating system. Let me write it down here. So here, what we have is a terminal OS. What's the other one? Windows one? What do we call it? A console-based, the image that we have seen. This is the major difference, guys. This was the original difference. So Windows is a console-based. Linux or Unix, forget Linux for now, sorry about it. Unix is a terminal-based operating system. So when we say terminals, we are basically talking about these things. Each one is a terminal. Each one is a term. You can connect as many terminals as you want. Now, how does this terminal look like is this thing. Let me show you a quick Linux terminal. You're all familiar with those terminals, but I'll just show it to you once. This is one of the tools to connect to a Unix system. We will talk about it later. So I have a remote system with this IP here, you're saying. I'm trying to connect to that server. It's sitting somewhere in Germany in a data center. This is your Linux server. And this screen that you are looking at, the black screen, is a terminal. So we are connected to some server sitting in Germany. Let's get a visual idea of what exactly we are trying to do on a map. If I say a world map quickly, where are we? Oh. So the terminal that I just used basically started here, somewhere here in Hyderabad. Where are we in Germany? Is here, is it? So basically we traveled across half of the world to connect to the server using the terminal sitting here. Now this is the exact same thing that you would be doing in a real world scenario. Your servers will be sitting somewhere in United States. All the Java code that you are writing is here in Hyderabad or Bangalore. And when you transfer your code, you're sending it to all the way back to United States. So here your Linux server is sitting. And you are connecting to that Linux server using what? A terminal. That's the actual visual picture. You got a visual idea of what is happening when we say a terminal versus a console? When you say console, it's like you have a laptop right in front of you. You are plugging in a cable. Physically, you are in front of it. Whereas a Linux server, you will visually try to see it's somewhere there. This whole group of people is trying to simply open a terminal, connect to the server. So everything that we are seeing here, it could be same user or it could be different users. Now this is where Unix became more popular. Because in old days, you have seen just now how big those computers were, right? These are all transistors. This is one of the computers at the very beginning. See, 1950 main programmer. This is one of the computers. Can you imagine? This is a computer. This does not look like a computer. Look at the current laptop you are looking at. You have it in your hand, isn't it? Your mobile is almost like a computer. The recent OnePlus mobile, it has some 16 GB RAM. This laptop that I'm using has almost 16 GB RAM. So compare the old days servers with what we are using now. Almost we are 70 years we've traveled through this computer technology. Therefore, everything changed. So instead of once upon a time, instead of sitting in front of a Windows server and trying to connect, Unix servers or Unix operating system based computers have allowed multiple users. Now, the reason why this was popular or why even it's created is this whole Unix thing was created in a college, university. And they wanted a lot of labs for their students and PhD scholars. The PhD guys are the ones who are doing the research. Now, obviously, they are sitting at different places. different rooms. Even within a room, if they come in, obviously they have to sit next to each other. Now, if they are sitting next to each other, each one of them should be able to connect to the same Unix server central. That was the requirement that allowed them to create this thing. Everybody wanted to connect to same server. The reason why they wanted to connect means, you can ask me, why sir, why do they need to connect to the same one? They can have their own one, right? Two problems. One is cost. Just now you've seen how big the computer was. Nobody is going to give enough money, especially universities, colleges. They'll say, your computer is already useless. It's not doing anything. We are not going to spend more money on it. First thing, that is cost. The second thing is all the research that these guys are doing is sitting on this Unix single server only. If they have another server, they don't know how to transfer this thing from here to there. That technology is not developed at that point of time. Not like you are taking a photo and uploading to Instagram instantly. That's not happening. That was long back, Vedanta. Right now, you don't even know you're uploading to Instagram. It happens automatically. That time, everything has to be done manually. So we are talking about why things have changed. It's like, why human beings are human beings, why monkeys are monkeys. We had a different requirement. Over the years, we became different. Monkeys had a different requirement. They became different, even though we started at the same time. Almost similar in knowledge. All right. So the summary point here, probably you can write it down. I want to repeat that point again and again, because this is one thing that everybody is really confused about. When people say Windows versus Unix, everybody says it's more secure. It has GUI, that doesn't have GUI. No, they are all value additions. The core difference is one user versus multi-users. Even now, that's the biggest problem. For example, right now, I'm using my laptop, right? This is a Windows laptop. If I ask you to connect to it, I have to log out. The Windows 10 that I'm using has no feature to allow multiple users. But if I'm using a Linux laptop, you can quickly connect to the same server, see all the files that I'm seeing. Because that's a terminal-based operating system. So let's write it down somewhere, like key points. I will add it to the notes, but still you can write it down. So I'm going to maintain a small box here. Into this box, I'll write down all the key points. All right. So the first thing, Windows it's a single user OS, or otherwise called as console-based operating system. Whereas Unix is a multi-user operating system. In other words, called terminal-based operating system. Are we doing it directly live on the G drive? Let me create a quick document. You'll need a URL. Copy the link. Post it. you also will be able to access it, right? You will get this link later. Now you can access it now. Okay. Anyway, we'll share this at a later point of time if you need. So let me write it down here. So Windows is a single user OS or console-based operating system. And what is Linux or Unix, for example? We will talk Unix versus Linux later, once we get some idea about this. Multi-user OS or terminal-based OS. You can say multi-user or multiple user, anything you want. All right. So that's a major difference. Apart from this, there are some other key differences. We will see those differences also to get the complete picture of why somebody should use Windows versus why somebody should use Unix. And once we understand the difference between Windows and Unix, then we will introduce the third component. What's the third component? The Linux. All right. So here, after Windows and Unix, we're going to introduce a third component, Linux, but later. First, we will see some more differences between Windows and Unix. The first one is single versus multiple. All right. Even when we are saying multiple again, this is something that you have to reiterate. A same user can log in, means you can use the same ID that I am using. For example, if the user ID is, let's say, Durgasoft 1. So this user also can use Durgasoft 1. Whereas this user will be using Durgasoft 2. And the other user would be using Durgasoft 3. Make sense so far? Any questions? There are some questions about, can we use MacBook? Will I be able to install these softwares in MacBook? No, MacBook is a different operating system. Apple computers have developed a different operating system called iOS. It is based on Unix. So if there is a software that can be installed on Unix, many times it can also be installed on iOS. So MacBook and Unix, they do have a lot of overlapping. So some softwares that can be installed on Linux or Unix can be installed on MacBook. Couple of other questions about WebSphere console, multi-user. WebSphere console is a complete different concept than Linux console. When we say Linux console here, we are talking basically about logging into the system, whereas WebSphere console is like an interface. For example, if you say Gmail, this is a login console. If you log out, give me another thing. Anything else? Let's see, Facebook. Not logged in, I think. Yeah, this is a console. This is also called a console because it's asking you for username password. So the WebSphere that you're asking is similar to what we are looking on the screen, Facebook. So we are not talking about this type of console, not the Facebook console. You also have a console on Tomcat. How many of you are familiar with the Tomcat console? If you are deploying a jar file to your Tomcat server, you will have a console over there. Those consoles are basically consoles to log into your software, existing software. We are not talking about those consoles. We are talking about logging in into a system, like you log into my laptop. That's what we are talking here. All right. So the WebSphere thing is completely different. You can forget the WebSphere part. Now coming back here, after we understand that Windows is a single user operating system or console based operating system, and Linux or Unix for that matter is a terminal based. Let's look at some other important stuff. Means, are there any other differences? Now is the time to give all the answers that you gave yesterday. You told me a lot of things yesterday. They are all valid answers. Can you recollect what you said yesterday? Windows versus Unix we are talking right now. Any answers? Any guesses? The first thing that comes to your mind or anybody's mind is this is a graphical user interface versus Unix is a command line interface. That's the second thing. Let's write that down and see if that is true or not. So the second thing that we are talking here is Windows GUI, graphical user interface, versus Linux or Unix command line interface, CLI. Let me write that down. Those two things also, graphical user interface and command line interface. These are the two words that you come across a lot of times. GUI, CLI. GUI is graphical user interface. And CLI is command line interface. Let's look at these two things. Is it a real difference or it's not? First, we will see with Windows. Everybody agrees Windows is a GUI thing, graphical user interface. It's all graphical, right? So we are looking at, mostly we work with a mouse. I'm working with mouse. If I have to go somewhere, I just click on it. I'm clicking on start button. If I have to open a browser, I'll click on it. All right. Then if I have to open a folder, I click on it. If I have to open a file or folder, again, click on it. So you can see everything, right? You're not running any commands. You're not writing any programming here. So this thing that you are looking at, this whole thing, is the graphical user interface. This is graphical because all our images, windows, everything. User interface, we are the users who are using this laptop or this operating system. Interface is because that's how we are seeing everything on the hard disk. All your files are stored on the hard disk, right? And how we are seeing things on the hard disk from this, interface. You have a window open, so that's an interface. You have a file open, that's an interface. That's the kind of thing what interface is. So here, Windows, we know it's mainly graphical user interface, isn't it? Now the important question. What about CLI? Is there a CLI for Windows? There is no command line interface on Windows. Command prompt we have. You know that, right? Even if you don't, let me show it to you. So this is what your command line is on Windows. You click on your search button or somewhere nearby. You type CMD command, double click it, it opens. Your command line. This is your command line. Now I'm going to type the same command, which is equivalent to clicking on a folder. If you double click on folder 1 here, what will happen? You will see everything inside that folder, right? So what is happening here is, it's the double click is opening that folder. So let me go back here. Double clicking on folder 1 now, it opens it. Now, can I do the same thing on the CLI? This is the graphical user interface that you have just used. And what's the task you have done? You tried to see the contents of a folder. You tried to see what are the files inside the folder. Now let's try the same thing on CLI. First thing, I have to be in that directory, right? This is the directory. I'm in C users